What's up, gang? Today we're going to be talking about the scientific method. Now, the scientific method is really just a list of steps that we use to solve a problem. And it doesn't just work with science, it really works with pretty much any problem that you want to try to find an answer to. Like I said, it's not really a set of rules so much as it is a set of steps. So go ahead, take out that notebook and pencil. I'm going to grab some coffee and we'll get started. Now, there are a bunch of steps to the scientific method, and the scientific method can look kind of different depending on who you're talking to. But we're going to talk about the main steps. The first thing that you need to do when using the scientific method is you need to state a problem. You need to answer a question. Why is this doing this? What's causing this to happen? You want to find an answer. And so the first step that you're going to do is you're going to form a hypothesis. And a hypothesis is really just an educated guess of why you think something is happening. If you throw a ball, how far will the ball go? Well, your hypothesis is the ball will travel the distance of, how hard you throw it. That might be your hypothesis. Now, when you form a hypothesis, you want it to be based off of a trend of something that you think is happening. Like I said, it's an educated guess. So the first step is forming a hypothesis, and the second step is going to be conducting an experiment. When you conduct an experiment, you need to have consistency. When it comes to science, the thing that's going to help you the most is going to be how consistent you are with the experiment. If you can continue to be consistent, then your experiment's going to work and your data is going to be good. The third step to forming the hypothesis, or the third step to the scientific method rather, is you actually want to make an observation based on what's happening when you do the experiment. So you have a list of things that you're going to do to try to solve a problem or answer a question. Then you're going to make an observation. There are two types of observations that you're going to come up with. The first type of observation is something called a qualitative observation. The qualitative observation really depends on the quality or what you can see happening when you do the experiment. For example, does the experiment change colors? When you mix two things together, does it change from yellow to pink or from purple to pink, pink to yellow? That's a qualitative observation. The second type of observation that you need to be aware of is a quantitative observation. And if you can use context clues, then you can probably guess that quantitative observation, typically quantitative observations have to do with numbers. For example, going back to that ball example, how far I throw the ball, a good quantitative observation would be the distance in meters or an actual measurement that ball travels. And measurements are just ways for us to keep consistent forms of data. Now, we're going to be using the term data a lot, especially in the lab. Data is pretty much anything that you record or information that you get back from doing an experiment. And I have to tell you, the data is the most important part when it comes to the scientific method. So many times I've seen people try to use the scientific method with experiments, but they don't look at trends in their data. What's actually happening? This is the most important part because this is where you can form a solid conclusion to your scientific method, or to your experiment, Now, if you come up with data that doesn't support your hypothesis, you're not going to go straight to a conclusion. You're going to basically go back and change your hypothesis. Well, my original idea was that this was happening because of this, but now it's not really happening anymore, so I need to change my hypothesis. And then when you do that, you go back and redo the experiment, see if your hypothesis then supports the data, or if the data supports your hypothesis, rather. And if it does, that's when you can get to a conclusion. And a conclusion is basically just your summary or what you got to at the end of the experiment.